Alright, so in this video we are going to solve a trig function by methods of derivative or differentiation, and the problem reads that Landon James is a top business owner who specializes in constructing massive ice skating rinks. So he wants to construct a new ice skating rink with sides L for meters and the semicircle's radius R for the ends. What we are finding is what are the largest values of L and X that produce the largest area inside of the track. So the entire perimeter is also 800 meters. Alright, so the first thing we're going to do is draw out our situation, our diagram of the problem. And we're going to do this entire process in steps. So we're going to start out with our first step, and this is the first step. And we're also going to write our given information since we have the perimeter P equals 800 meters and also the circumference 2 pi r since the two semicircles of the track is included. We have to include 2 pi r, and we're going to label the semicircles as x because the radius is x in this case, and we're going to label the sides, the outskirts, as L, both of which are meters. This is the first step. So the second part is to find a general equation to solve for the area, and as you can see, the box solution is our general equation, which we're going to use with a couple of other general equations to find the area, which is what we're trying to solve overall for the problem. Now for this problem we're going to start out with what we already got. The information we already know is that the perimeter of the rectangle inside of the skating rink is 2L, and then since there are two semicircles on the outside, then the perimeter of that would be 2 pi r, and we'd set all of this equal to pi because this is the entire perimeter of the skating rink. Now we can plug in the information that we received from the beginning of the problem. 800 meters equals to the perimeter, so we'd set 800 equal to 2 pi r plus the 2L. Now we're going to plug in the r as x because the L and x are the variables we are using to find the area, so we get 800 equal to 2 pi x plus 2L. And then when we cancel out the 2, a lot of people get tripped up with that. We're taking out 2 out of both sides, so we get 400 equals pi x plus L, and this is the first general equation that we are going to use to find the rest of the variables. Alright, so the next step of this problem is to figure out our constraints, and this is already done before since we found the perimeter, it was given to us, but constraints are what information that we'd gather that's not exactly stated in the problem, but information we'd get from what we were told from the problem, and that is the circumference of the two semicircles, the perimeter of the entire rink, and the area of the circle. Because the two semicircles plus each other equal to a total circle. I'm going to split this up into A and B, and the first part is A equals pi r squared, which is the area of the circle, and we're going to find the total area of the entire perimeter of the skating rink. So we label that AT equals pi r squared plus 2XL. Then 2XL comes from the area of the rectangle inside of the skating rink. Since the sides are L and X, then we would get AT equals pi x squared plus 2x. Now we're moving to XL. Now we're moving on to part B, and that is setting the equation that we got, the general equation that we discovered, to the total area equation that we just formulated. So we would get 400 equals pi x plus L. Now minusing the pi x from both sides to find L, we would get 400 minus pi x to get the L, which is the first variable that we need in order to solve the area. So moving on to part B, we're going to plug in the information that we got from part A. So the total area that we got was pi x squared plus 2xl, and we found what L was. L was 400 minus pi x from our original formula. So we got AT equals pi x squared plus 2x times 400 minus pi x. Now simplifying that, AT equals pi x squared plus 800x minus 2 pi x squared, and then AT equals 800x minus pi x squared, because the pi x squared minus 2 pi x squared cancel each other, not cancel each other out, but equal to negative pi x squared. So our general equation is this, f of x. Now, step 4 and 5 is finding the first derivative of our function and setting that equal to 0. And our function is f of x equals to 800x minus pi x squared. Sorry, you can't see that. And the f prime of x equals to 800 minus 2 pi x. And this is so because the x to the first power, which is not usually written, turns into a 0 because the 1 is put to the side. And then the pi x squared, the 2 is brought down in front of the pi x, so it's minus 2 pi x. Now, setting the first derivative to 0 is step 5. So the f prime of x equals to 800 minus 2 pi x. We set that equal to 0, so 0 equals 800 minus 2 pi x. And we subtract 800 from both sides, and we end up with negative 800 equal to negative 2 pi x. And then we can divide each side by negative 2, and we result into 400 equals pi x. And again, divide each side and divide by pi, and you get x equals 400 over pi. Now, step 6 is finding out if the x is a possible solution or if it is extraneous or not. And we're going to solve this now. Alright, so this part is a little bit tricky to understand, but this is as simple as I can explain it. Since we found the L to be 400 minus pi x, we can conclude that 0 is less than or equal to L, as L is less than or equal to 400, because the solution of L is 400 minus pi x. So that means L has to be bigger than 0, which also means that pi x has to be less than 400. So pi x is less than, so if pi x is less than 400, we can figure that out formula-wise and divide each side by pi to figure out what x is. And we end up with x being less than 400 over pi. Now this makes sense since the solution we got for x in our previous step is 400 over pi. X has to be greater than 0 in order to fit the extraneous formula or not. So 0 is less than or equal to x, as x is less than or equal to 400 over pi. And since 400 over pi is exact, that means this is a possible solution of x, so it is not an extraneous solution. So for 6, we're going to continue on and find the value of L since we found the actual value of x. Now, we're going to go back to our perimeter equation since it is the easiest equation to use since it has both x and L in it, and it's the most simple. 400 equals pi x plus L, and we plug in our x solution, so we get 400 equals pi times 400 over pi plus L. And then we move on to 400 equals pi over 1 times 400 over pi plus L to just make it easier and cancel out the pi's. We get 400 equals 400 plus L and subtract the 400s from both sides, and we get that L is 0 from this. Now this makes sense. We're going to figure out why it equals to 0. Alright, so step 7 is our calculations in order to inspect the solutions that we got and see if they're accurate or not, and we're going to do this by using the second derivative, or f double prime. Now we use the first function that we got, which was 800x minus pi x squared, and we use that to find our first prime, our first f prime, which is 800 minus 2 pi x, and the double prime becomes negative 2 pi because the x cancels out. Now, the f double prime of any number of this solution will always be negative 2 pi, so that means it will always be negative. That in turn, I'm sorry you can't read it, that in turn means that the solution is maximum, that this will always be the maximum. This makes sense because our values that we got are L equals 0 and X equals 400 over pi. Now our conclusion is that for the largest possible area for the ice skating rink is the length being 0 and the radius x being 400 over pi. This is because that the largest possible area for the ice skating rink will always be a 0. There cannot be any straights when dealing with this type of structure because the largest possible area for any given perimeter is a circle, and since there are two semicircles, this makes sense. There cannot be any straights, essentially.